From getting lost in the supermarket to going on the rocking horse at playschool, memories from before the age of 5 are few and far between for most people. This is due to childhood amnesia, which refers to the inability of people to remember anything from before the age of around 3.5. During childhood, brains are more limber, which means they are able to absorb lots of information in a small space of time. However, parts of the brains that retain this information are still under construction, scientists say, from birth until our early teens. Essential circuitry in the brain is still being laid down as electric pathways become lined with fatty tissues to become more conductive, meaning we are able to retain these memories in the process. Memories from our limber childhood brain are likely to become inaccessible as our neurons are restructured in the formation of our adult brains. This is a phenomenon of long-standing focus. Patricia Bauer of Emory University, a leading expert on memory development, told Nautilus as part of an in-depth feature it was previously thought children were unable to retain memories before the age of 7. However, in 2005 researchers found 5.5-year-olds remembered 80% of things that happened when they were 3. By the time they reached 7.5, they remembered less than 40%. This shows children can remember things, but that these memories start to fade in the past few years. Scientists have been finding out about the biological basis for this memory loss. Throughout childhood, the brain is laying down circuitry and lining key pathways with fatty tissue. During this period of growth, new bridges are created between neurons, according to experiments by Paul Frankland, a neuroscientist at the Hospital for Sick Children in Toronto. The growth of new neurons in the hippocampus is essential for remembering and forgetting. Not only do these parts of the brain degrade, they also become concealed as we age. Dr. Frankland and his wife Jocelyn carried out research on adult and infant mice kept in cages. One cage was the size of a shoebox and the other much larger. The mice were given mild electric shocks when placed in the larger cage. The older mice stiffened with fear when they were put in it, in anticipation of the shock, while the young mice forgot about it in the space of a day. However, when the adult mice ran on hamster wheels after their shock, they forgot their pain. This is because it stimulated the growth and development of nervous tissue, a process called neurogenesis. Childhood amnesia refers to the inability of people to remember events from the early years of their lives, typically before 3.5 years old. Females appear to have better memories for this than men, and on average could go back further than men. There are a number of theories about why this might be happening. The most controversial was put forward by psychoanalyst Sigmund Freud, who believed it was a response to war repression. Another theory suggests childhood amnesia is down to a lack of language skills before the age of 3. It was previously thought children were unable to retain memories before the age of 7. However, in 2005 researchers found 5.5-year-olds remembered 80% of things that happened when they were 3. By the time they reached 7.5, they remembered less than 40%. This shows children can remember things, but that they don't last for as long as things that happen in adulthood. When researchers gave the mice specific drugs that hindered neurogenesis, the young animals were able to remember things better. By inserting a fluorescent protein into the DNA of the mice's brain, they found neurogenesis did not wipe out memories, but restructured them so much the original memories were harder to recall. In humans, experts believe the same thing is happening. We think it's an accessibility issue, but it's sort of a semantic issue too, said Dr. Frankland. If a memory becomes impossible to access, then it is effectively erased due to these cycles of growth and decay. Any memories that do survive childhood are likely to be blends of genuine recollections and things that we've heard or dreamt up. Beginning in the 1950s, studies of the famous amnesiac patient Henry Molaison revealed that the hippocampus is essential for forming new long-term memories. Molaison, whose hippocampus was damaged during an operation meant to help control his epileptic seizures, was no longer able to store new memories after the operation. However, he could still access some memories that had been formed before the surgery. This suggested that long-term memories of specific events are stored outside the hippocampus. Scientists believe these memories are stored in the neocortex, the part of the brain also responsible for brain functions such as attention and planning.
Where the freaks at?